Have you ever created a child class that seemed mathematically correct, but somehow caused your entire application to crash? It's a common mistake, and it usually happens because you violated the Liskov Substitution Principle. Introduced by Barbara Liskov in 1987, this principle is the L in the solid design pattern. If S is a subtype of T, then objects of type T may be replaced with objects of type S without altering the correctness of the program. The academic definition is a bit of a mouthful, but here's the plain English version. If you have a parent class and a child class, you should be able to swap them out without the user knowing the difference. If the child class starts acting weird, you've broken the principle. To understand this, let's look at the classic square versus rectangle problem. First, we have a standard rectangle class. It has a width and a height. Crucially, the behavior here is that if I change the width, the height remains unchanged. They are independent. That is the expectation of this class. Now, in geometry, a square is a rectangle. It's a special type of rectangle where all the sides are equal. So, as a developer, it feels natural to make a square class that inherits from rectangle. But here's the catch. To enforce the rules of a square, if you set the width, you must also automatically change the height to match. We override the setters to link the two dimensions. Here's where the code breaks. Imagine a function somewhere else in your app that takes a rectangle as the argument. It sets the width to 5 and the height to 10. It expects an area of 50. But if we pass in our square, which we're allowed to do because of inheritance, setting the height to 10 effectively overwrites the width we just set. The area becomes 100. The child class has changed the behavior in a way the parent class never intended. This brings us to the core of the Liskov Substitution Principle. Inheritance in programming is about behavior, not just sharing properties. Even though a square is a rectangle geometrically, it behaves differently because the square class restricts the independence of width and height. It cannot be substituted for rectangle. So, how do we fix this? We stop forcing the inheritance. Instead, both square and rectangle should perhaps implement a common interface, like shape, which simply asks for a getArea method. By separating them, we respect their distinct behaviors while still keeping our code clean and polymorphic. To wrap up, a subclass should extend the capability of a parent, not replace or break it. If you have to check, is object of type X in order to avoid bugs, you're likely violating LSP. If you found this explanation helpful, please drop a comment below and subscribe for more design pattern breakdowns. Happy coding.